Hello guys, today we'll be doing a 2003 AP Physics C free response. Unlike the usual board, today we're going to just have to use paper and pencils because the board is currently being used by my father. So, this question reads, in the laboratory you connect a resistor and a capacitor with unknown values in series with a battery of EMF E equal to 12 volts. You include a switch in the circuit. When the switch is closed at time t equals 0, the circuit is completed, and you measure the current through the resistor as a function of time as plotted below. So notice the graph. Time is along the x-axis, and the current is along the y-axis. And underneath it says that a data finding program finds that the current decays according to the equation I of t is equal to E over R, E raised to the negative t over 4. This is the fundamental constant that we have. And this is the volts, that's the resistance, this is the current, that's the time. And so, using this, let's continue. Part A simply wants us to draw the circuit. What we need to remember is that this has one resistor, one capacitor, one battery, and a switch. So they want us to draw the circuit, and along with the circuit they want us to use whatever other devices we need to measure the current through the resistor. So let's just know what we're looking for in our current. A switch, battery, resistor, capacitor, and so if we are looking to measure the current, we need an ammeter. So that's that. Alright, so let's build our circuit now. Here's the battery. 12, 0, 0. We'll put our switch here. We need one resistor. This is the capacitor. Resistor, capacitor, and then we need our ammeter. And the one thing you need to remember is it always has to be in line with that, you know. And then I believe that's all there is to part A. Part B says, having obtained the curve shown above, determine the value of the resistor you placed in the circuit. So this is part B. V equals IR. This is the fundamental formula that we know. And we're looking for R, so V over I equals R. Now, you may be confused about what I to use, but you always use the I that you started off with. So, plug that in. We have 12.00 volts divided by 0.010 amperes. And that gives us 1200 ohms of resistance. Hold on, I'm not playing safe with sig figs. I think it should actually be 1.20 times 10 to the third ohms, and there shouldn't be an R. So sorry for getting sloppy, but that is the right answer now. And then part C asks us, what capacitance did you insert in the circuit to give the result above? This part was a little confusing for me, and you just need to, there's this one big clue in the question, and you need to recognize that clue in order to solve this. And so look at this formula that they gave us, and we haven't used the formula at all yet, so it makes sense to use it for part C. If you look, it's really similar to another formula we know, which says that, and you guys have probably seen that, and we know that that funny letter, I think it's tau, is equal to RC. And this is what we want, because we know that they've given us that tau equals 4.0 seconds. just because if you look here in the equation, that's the denominator, so that's equal to tau. And so we have r, we have tau, and we can solve c, which is going to be t over r equals c. And this is simply 4.0 seconds divided by 12.00 ohms, and that gives us 3.3 times 10 to the negative 3 Faradays, and I mean you could get that simply by plugging it into a calculator. And with that, guys, we have successfully completed the free response that we were going to do today, the 2003 APC.